Look around you right now. What do you see? A room, a city, the sky. But there is an invisible force shaping almost everything you do. It is a force that holds messages on your refrigerator. It helps your car start. It powers the music you hear and the screen you are looking at. This force is magnetism. It is one of the fundamental forces of the universe. And yet we often forget it is there. It works silently, invisibly all around us all the time. It is a quiet giant, a hidden architect building the framework of our modern world, one magnetic field at a time. It's a cosmic secret hiding in plain sight. We live in a world built on magnets. Think about that for a moment. From the tiniest electronic component to the largest industrial generator, magnets are the key. They are not just simple toys that pick up paper clips. They are sophisticated, powerful tools that have enabled our greatest technological leaps. Without them, our global communication systems would fail. Our ability to generate electricity would be drastically reduced. Our lives would look very different, more like the world of a century ago than the world of today. The story of human progress in the last 100 years is, in many ways, the story of mastering this incredible, invisible power. The universe itself is deeply magnetic. Stars like our own sun have immense magnetic fields. Planets, including our Earth, have them too. Earth's magnetic field protects us. It creates a shield, the magnetosphere, that deflects harmful radiation from space. This cosmic shield makes life on our planet possible. So the same force that sticks a note to your fridge is also the force that guards our entire world. It connects the smallest things in our homes to the largest structures in the cosmos. It's a beautiful, elegant symmetry that reveals the interconnectedness of everything. We are, in a very real sense, children of a magnetic universe. Understanding this force opens up a new way of seeing the world. It's like putting on a new pair of glasses. Suddenly you see the hidden connections. You understand how a simple spinning motor works. You grasp the genius behind storing vast amounts of data on a tiny hard drive. You appreciate the power of a wind turbine generating clean energy. The world stops being just a collection of objects. It becomes a dynamic, interconnected system, humming with invisible energy. And it all begins with the simple, mysterious, and powerful force of magnets. The journey to understand them is a journey to understand our own civilization. Let's take a walk through your day. Your morning starts with an alarm. If it came from your phone, magnets were involved. The tiny speaker that made the sound uses a small magnet and a coil of wire to create vibrations. You go to the kitchen to get some milk. The refrigerator door seals shut with a magnetic strip, keeping your food cold and fresh. You might see photos and lists held to the door by decorative magnets. These are your most obvious magnetic friends. But the machine itself, the refrigerator, uses an electric motor with magnets to run its cooling system. Your kitchen is already a magnetic playground. Now, you decide to leave the house. If you get into a modern car, you are stepping into a magnetic powerhouse. The engine starts with an electric motor. The power windows go up and down with motors. The windshield wipers use motors. All these motors work because of magnets. But it goes deeper. Your car has sensors everywhere. Sensors for speed, for engine performance, for the anti-lock braking system, ABS. Many of these sensors use magnets to detect position and movement. And if you are driving an electric car, you are basically sitting on top of a very large, very sophisticated set of magnets that turn electricity into motion. Let's think about your entertainment and communication. The headphones you use to listen to music or a podcast contain small but powerful magnets. These magnets are essential for turning electrical signals into the sound waves you hear. The computer or phone you are using to read this has magnets inside. The hard drive, if it has one, uses tiny magnetic fields to store every single piece of data, every photo, every document, every song. Even solid-state drives, or SSDs, rely on principles of electromagnetism. The fans that cool your computer are spun by magnetic motors. Magnets are the silent partners in your digital life. Even your money depends on magnets. Your credit and debit cards have a dark magnetic stripe on the back. This stripe stores your account information in a magnetic code. When you swipe your card, a reader detects this magnetic information to complete your purchase. From the moment you wake up to the moment you go to sleep, you are constantly interacting with magnets. They lock our doors, they help us cook, they power our transport, they store our memories, and they handle our transactions. They are the invisible, indispensable companions of modern existence, quietly making everything work. So what is this magical force? What makes a magnet a magnet? At its heart, magnetism is a fundamental property of matter. It comes from the movement of electric charges. Inside every atom you have tiny particles called electrons. These electrons are not just sitting still, they are spinning and orbiting the atom's nucleus. This movement creates a tiny magnetic field. In most materials like a piece of wood or plastic, the electrons spin in all different directions. Their tiny magnetic fields cancel each other out. The material as a whole is not magnetic. It's like a room full of people all talking at once, it just becomes noise. But in some special materials something amazing can happen. In materials like iron, nickel and cobalt, the atoms can be convinced to line up. Imagine that room full of people, but now everyone is singing the same song in perfect harmony. When the tiny magnetic fields of billions and billions of atoms all point in the same direction, they add up. Their small forces combine to create one large, strong magnetic field. This is what we call a magnet. This unified field extends out from the magnet into the space around it, creating an area where it can push or pull on other magnetic materials. Every magnet has two ends, which we call poles. There is a north pole and a south pole. This is a fundamental rule of magnetism. You can never have a magnet with just one pole. If you cut a magnet in half, you don't get a separate north and south pole. You get two new, smaller magnets, each with its own north and south pole. It is a law of the universe, and these poles have a simple relationship. Opposites attract and likes repel. The north pole of one magnet will pull strongly toward the south pole of another, but two north poles will push each other away. This simple rule of attraction and repulsion is the basis for how all magnets work. This invisible area of influence around a magnet is called a magnetic field. You can't see it with your eyes, but you can see its effects. A classic experiment is to sprinkle iron filings on a piece of paper placed over a magnet. The tiny iron pieces will trace out the lines of the magnetic field, showing you the shape of this invisible force. The lines flow out from the North Pole and loop around to the South Pole. The closer the lines are together, the stronger the magnetic force is. This field is what allows a magnet to act at a distance, to pull a paper clip from across a small gap, and to make the modern world turn. The invisible power of magnets is now at the center of our fight for a cleaner planet. Modern life needs huge amounts of energy, but burning fossil fuels is changing our climate. We need new, cleaner ways to power our world. Magnets are the key to this green revolution. They are essential for converting natural forces like wind and motion into the electricity we need. They are helping us build a future that is not dependent on oil and gas. This transition to clean energy is one of the most important challenges humanity has ever faced, and magnets are one of our most powerful tools to meet it. Consider the giant wind turbines you might see spinning slowly on a hillside or out at sea. How do they work? The wind pushes the blades, making them turn. Inside the turbine, this rotation spins a generator, and at the heart of that generator are powerful magnets. As the magnets spin past coils of copper wire, their magnetic fields create an electric current. It's a beautiful process called electromagnetic induction. The stronger the magnets, the more efficient the generator is, and the more electricity you can produce from the same amount of wind. These are not your simple refrigerator magnets, they are huge high-tech wonders. Electric cars are another cornerstone of our green future. They produce no tailpipe emissions, helping to clean the air in our cities. The magic behind an electric car is its motor. This motor uses electricity from a battery to create powerful rotating magnetic fields. These fields push against other magnets, causing the motor to spin and turn the car's wheels. To make these cars light, powerful and efficient, they need very strong magnets made from special materials. The performance of an electric car, its speed, its acceleration, its range, is directly linked to the quality and power of its magnets. This connection between magnets and energy is fundamental. Almost all the electricity we use, whether from coal, nuclear, or wind, is made using generators that rely on magnetism. They are the bridge between mechanical energy and electrical energy. As we move towards a more sustainable future, the demand for high-performance magnets is growing faster than ever. We need them for wind turbines, for electric vehicles, for energy-efficient pumps and motors in factories. Magnets are no longer just a convenience. They are a critical component of our global strategy for a cleaner, healthier, and more sustainable civilization. The strongest magnets, the ones we need for green technology, are not made of simple iron. They are made from special elements called rare earth metals. These are a group of 17 elements on the periodic table, with names like neodymium and dysprosium. When you combine these metals with iron and boron, you get incredibly powerful permanent magnets, known as neodymium magnets. They are so strong that a small one can lift more than 1,000 times its own weight. This amazing strength is what makes our compact, high-performance electronics and green energy technologies possible. Without them, our phones would be bigger, and our electric cars would be weaker. Here is the challenge. These rare earth metals are not actually that rare in the Earth's crust. The problem is that they are very difficult to mine and process. They are often found mixed together in low concentrations. Separating them into pure forms is a complex, expensive, and often environmentally damaging process. For many years, only one country has truly mastered this process on a massive scale: China. Today, China controls a huge majority of the world's rare earth mining and, even more importantly, the processing. This means they produce most of the powerful magnets the rest of the world needs for its technology. This reliance on a single country for such a critical resource creates a major problem for the rest of the world. It makes global supply chains vulnerable. If there are trade disputes, political tensions, or changes in policy, the supply of magnets could be restricted. This could slow down the production of everything from military equipment to electric cars. For many nations, this is a serious issue of economic and national security. Imagine trying to build a new fleet of wind turbines or switch your country's cars to electric, only to find you cannot get the essential parts. This is the situation the world is facing. In response, a new global race has begun. Countries around the world, including the United States, Australia, and nations in Europe, are working hard to change this situation. They are investing billions of dollars to create their own supply chains for rare earth metals and magnets. This means opening new mines, building new processing plants, and developing the expertise to compete. It is a slow and difficult process, but it is seen as essential for future independence and security. The quiet, invisible magnet has become a major character in the drama of global politics and economics. The race for magnetic control is on. The story of magnets is far from over. In fact, we are entering a new golden age of magnetic innovation. Scientists and engineers are pushing the boundaries of what is possible, finding new ways to use this fundamental force to solve some of our biggest challenges. One of the most exciting frontiers is in medicine. You may have heard of MRI, or magnetic resonance imaging. These machines use a giant, super powerful magnet and radio waves to create detailed images of the inside of the human body without any harmful radiation. They allow doctors to see our organs, tissues, and bones with incredible clarity, helping to diagnose diseases earlier and more accurately. But the future of magnets in medicine goes even further. Scientists are developing new techniques using magnetic nanoparticles. These are tiny magnetic particles, thousands of times smaller than a human hair. They can be coated with medicine and injected into the bloodstream. By using external magnets, doctors could guide these particles directly to a tumor or a specific diseased area in the body. This would allow for targeted drug delivery, attacking the illness while leaving healthy cells unharmed. It is a revolutionary idea that could change how we treat diseases like cancer. Magnets could become our tiny, guided messengers of healing. Magnets are also at the heart of our quest for limitless clean energy through nuclear fusion. Fusion is the same process that powers the sun. It involves forcing atoms together under immense heat and pressure to release huge amounts of energy. The challenge is containing the superhot material called plasma, which is hotter than the center of the sun. No physical container can hold it. The solution? A magnetic bottle. Huge, incredibly powerful superconducting magnets are used to create a magnetic field that contains and shapes the plasma, keeping it from touching the walls of the reactor. Projects like ITER in France are giant magnetic machines, representing our best hope for unlocking this ultimate energy source. From the data that runs our world to the stars we hope to reach, magnets are leading the way. New magnetic memory technologies promise to store more data, faster and more efficiently. In space, magnetic sails could one day propel spacecraft using the solar wind, just as Earth's magnetic field protects us. The truth is, we are still just scratching the surface of what magnets can do. They are not just historical artifacts or simple tools, they are a key to our future. They are the invisible force that will continue to shape our world, drive our innovations, and power our dreams for generations to come. The cosmos is magnetic, and so is our destiny.